Today we have a question that why magnetic monopole doesn't exist. So we can explain this from Maxwell's second equation. And we know the Maxwell's second equation is divergence of B equals to 0. And here B is a vector quantity and it is magnetic field. And from the definition of divergence, we know divergence of a vector field at any point is defined as the amount of flux diverging through a surface enclosing a volume, unit volume. That is closed integration B dot ds by volume V equals to 0. From here we can write closed integration B dot ds equals to 0. And we know closed integration B dot ds means phi, and that is flux. So flux must be 0. Total flux must be 0. Total magnetic flux must be 0 from Maxwell's second law. And this is, and first one, divergence of B equals to 0, that is Maxwell's second law in differential form, and closed integral V dot ds equals to 0, that is phi equals to 0. This is Maxwell's second equation in integral form. So now let's see how can we explain this question. Suppose we have a single pole, that is north pole, and its pole strength is qm. We take a surface S, and north pole act like a positive charge, similar like positive charge, and its magnetic lines of force are in outward direction, that is diverging in nature, like this. So if we take a small surface, small area ds, and area is a vector quantity, and area direction is perpendicular to the plane. So here ds direction will be in that direction, and magnetic lines of force also indicate the magnetic field direction, that is p direction. So from this the ds surface, phi will be d phi, flux will be d phi, that is b dot ds, b dot ds, b dot ds. But we need total flux. For total flux we have to integrate over that surface S. So phi will be close integration d phi, that is close integration b dot ds. But from here we can see, from that picture we can say magnetic lines of force are in outward direction, so total flux will not be 0. That means close integral b dot ds will not be 0, not equal to 0. But Maxwell second law, flux must be 0. So here is a problem. So now if we take a magnet, and here is a north pole as well as south pole, that is dipole like system, and again we take a surface S, and magnetic lines of force are emitted from north pole, and it goes to the south pole. So if we draw a line, magnetic lines of force, it will be like emitted from north pole and it goes to south pole, like diverging from north pole and converges to south pole. And we can draw another magnetic lines of force like that, like that. So from here, a small surface area ds, we can see that magnetic lines of force are in outward direction. That means flux will be positive, and flux is a scalar quantity. We can take outward flux is positive and inward flux is negative. And from that magnetic lines of force, from here we can see flux are in inward direction. As magnetic lines of force are inward direction, so flux will be in inward direction, so flux will be in negative. So here total flux from that surface will be 0, as inward flux is number of inward flux, number of magnetic lines of force in inward direction is equal to the number of magnetic lines in outward direction. So total flux must be 0, and total flux equals to close integration b dot ds. So it satisfies the Newton, so it satisfies the Maxwell second equation. So from here we can say that magnetic monopole doesn't exist. Whenever there is a magnet, there will, if there is a north pole, then there will be a south pole also. If we see there is a south pole, then there will be a north pole also. So north pole and south pole will be uh, together always. So this is it. If you have any other question regarding physics, regarding any topic in physics, so you can comment down below. I will try to explain in simplest way. So thank you.